Hello everyone. Today we are going to discuss Prim's algorithm. Prim's algorithm is a treaty algorithm that finds minimum spanning tree for weighted undirected graph. Now consider this following graph which we are going to solve using Prim's algorithm. We are going to find the minimum spanning tree of this graph using Prim's algorithm. Prim's algorithm is a different than Kruskal's algorithm. In Kruskal's algorithm, what we do is we find the minimum edges and we sort all the edges and then we connect the edges according to their weights. That's how we find the minimum spanning tree using Kruskal's algorithm. But in Prim's algorithm, there are some different points. Number one is to choose any arbitrary vertex as a root node. Number two is check all the adjacency nodes of that root node and choose the edge with minimum weight. And we will continue doing that until we have traversed all the vertices. Now, before going to the process, we need to keep in mind 2 points. Number one is loop and number two is parallel edge. If there is any loop or there are any loops present in our graph, then we have to remove that. And same goes for parallel edges. If there present any parallel edges, then we have to remove that edge. Now keep another thing in mind while removing the edges. Suppose we have a parallel edge from A to B which have a weight 10, and from A to F we have a parallel edge of 6. So we need to remove the parallel edges from A to B and from A to F. Now you may ask which one to remove. Now we have to remove the parallel edge which has more weight. That means in this one from A to B, this edge has more weight, and from A to F we have this one edge which has more weight. So when we are going to remove the edge, that parallel edge from A to B, we will remove this one. And when we are going to remove the parallel edge between A and F, then we will remove this one. Now in our graph there is no parallel edge, but if you have gotten a parallel edge or more than one parallel edges, then you have to remove the parallel edges like this. Now let's start solving this graph. Now as per our rule, we will first select any arbitrary vertex as our root node. Let's select A as our root node. Now we will check all the adjacent nodes from A. There are two adjacent nodes, one is B, another is F. Now from A to B, the weight of the edge is 4, and from A to F, the weight of the edge is 8. So let's write the weight here. Between 4 and 8, 4 is minimum. So we will choose this edge. Now what we will do is we will check all the adjacent nodes of A as well as B. So the adjacent nodes of B are C, G, and F. So this edge has a weight of 12. So we will write 12 here. And before doing that, we will remove 4 from here. Now we will write 12. One edge has a weight 2. This edge has a weight 6. And this edge has a weight 8. So we have written all the edges with their weights. Among these four, 2 is the minimum. So we will choose this edge. Now let's remove this weight 2 and let's focus on G. Now from G, there are two adjacency nodes. One is E, another is C. So the weight from G to C is 3 and the weight from G to E is 10. Now let's write that here. So among these 5 edges, 3 is the minimum. So we will choose this edge. Now consider C2. Consider this node. We have one node left, that is D, which has a weight 7. Another is 11. So among these edges, 6 is the minimum. So we will take this edge, that is this one. Now we will remove 6 and we will consider this vertex, that is F. Now from F there is only one vertex left, that is E, which in this edge we have 8, 5. So now 5 is the minimum. So we will choose 5. Now we have reached to the vertex, that is E. So from E we have two edges. One has weight 9, one has weight 11. So first we will remove 5 and we will write 9. So between 8, 7, 9, 12, 10 and 11, the minimum weight is 7. So we will choose this edge. That means this one. So this is our final MST, that is minimum spanning tree. See, we have traversed all the vertices. We have traversed A, we have traversed B, we have traversed C, D, E, F, and G. All the vertices we have traversed. Now, the value of this MST or the minimum spanning tree is 4 plus 6 plus 2 plus 3 plus 5 plus 7. That is 27. So this is how we find MST using Prim's algorithm.